Hello, in this video we are going to see the one case study about the finite automata. So already we know that what is a finite automata and what are all the types of automata. So first we will see the problem statement. For example, consider the scenario. There is a theater owner. That theater owner permits only the three categories of people. That means a father, mother and their kids for a show. The seating arrangement is restricted as follows. So the first option, any number of children can sit together. So the second one, the child followed by her mother can sit as a group. This can be repeated any number of times. The third option is that the child followed by her mother, followed by her father can also sit as a group. This can also be repeated by any number of times. The fourth option is the theater should not be empty. That means no child is permitted. So there is no one child is permitted. So for that scenario we have to derive the design of a automata. So in that scenario, first we will understand which type of automata we are going to use. So before that, we see about we have the recap of what is an automata and what is the type of an automata. So the solution is we have to construct an automata using the DFA that accepts only the valid seating pattern. So in that automata, so what is an automata means? Automata, it is a 5 tuples. So each automata contains a set of states, final set of states and final set of input symbols and starting state and final states and number of transition, that is the del symbols. So the finite automata is divided into the two types. One is the deterministic finite automata and non-deterministic finite automata. So what is the DFA or deterministic finite automata? For each state we have each input symbol transition that will go to the only one state, that is a deterministic. We have to determine the our state transition. So next is an NFA, that is a non-deterministic finite automata. The non-deterministic finite automata, from the state there is a transition in the state means we can go to the multiple number of states. So that can be done in the NFA. So the regular expression is we have to convert our regular expression into NFA. Yeah, that finite automata, it is a two types, all DFA and NFA. So DFA, all the DFA, every DFA is an NFA, but every NFA is not an DFA. So we are going to construct our problem in terms of using the DFA statements. So this is the difference between the DFA and NFA. So what is the main difference is that only in the transitions only, that is the DFA and NFA is differ. So in the DFA there is no epsilon transition. For each state there is a transition on that should be go to the only one state. That is the main function of the DFA. So the graphical representation of DFA means that it can be represented using the states are represented by the vertices and the arc labeled with an input character show the transitions. So the initial state is marked with an arrow. The final state is represented with the double circles. That is a representation of any finite automata. So next is a definition. So the definition again it should also have a 5 tuples that is described in the finite automata. So the 5 tuples are, it should have a Q, that is a finite number of states, and sigma, it is a finite number of input symbols, and transition symbol del is the transition function, and Q naught is the starting state, and final state is an F. So the transition function, when from Q to the input symbol transition, you should go to the some other states. So for example, this is a finite automata. This diagram is so the finite automata. For every input symbols there is a one transition that should go to the only single states. So in that diagram. From the diagram we infer that we have a 3 states. For example, the states are q0, q1 and q2. So what is the input symbol? The input symbols are 0, 1. The starting state is q0 and ending state is q2. So the solutions is from the q0 we have a 0 transition, means we go to the q0. If it is 1 means it is go to the q1. So for then q1, from the q1, if you have a 1 transition means it is goes to q1. If you have a 0 transition means it go to the q2. So the q2 we have a 0, 1 transition. So in the DFA we there is a simple tip in that for every DFA the last final state can have a self loop transition of 0, 1, but you should not have a transition self loop transition of 0, 1 in starting and intermediate states in the DFA. So the solution for our problem statement is, so what is the first scenario? Any child can sit together. So first start with the child, and from the q0 state it goes, when you read the child means go to the q1. So the q0 to q1 any number of child transition is accepted. So from the q1, suppose again you have a child arrives means that is can be accepted. Next is after that, after the second scenario is a second option is the child is followed by the mother. So the child is followed by the mother. First start with the q0, child is read, and after that q1 when the mother is comes it into the q2. So the at the q2, q0, q1, q2 the child and mother combinations is can be acceptable. So the third one is the child mother followed by the father can be accepted. So q0 to q1 is child transition, q1 to q2 is a mother, and q2 to q3 is a father. So that is accepted. These from these three states transition of child, mother and father is satisfied the third option of that problem. So suppose from the q2 we have any number of child means that is also acceptable. From the q3 any number of child can be acceptable. So this is a solution for our problem statement. So this DFA satisfied all our options of the valid sitting arrangement of my problems. So it satisfied the 4 categories of the valid seating patterns. So I hope you will understand how that DFA is constructed for the given problem statement. Thank you.